Welcome back to the channel, everyone. Now we're going to get a little bit more complex with our absolute value equations. Here we have a simple goal that we want to find. First, we want to, number one, isolate our absolute value equation, okay? Or in this case, isolate the absolute value, and then we can set up our positive and negative equations, okay? So those are the two goals that we want to have in mind here. The way that we're going to do that is we are going to use reverse order of operations just as you would solve normally, okay? So if you're thinking your order of operations here, if I were to take them in reverse, I might actually start with this addition and subtraction phase. So if I'm looking at this over here, I need to isolate this, that absolute value 3x plus 2, prior to actually setting up my positive and negative equations. So reverse order of operations, I'm going to look at this and say I'm subtracting this negative 11, I'm subtracting this 11 here. So reverse, I'm going to add 11 first. I'm going to add that to both sides. Then you have the absolute value of 3x plus 2 all over 9 is equal to 6. So that step is done. Now I'm looking at multiplication division. I have divided by 9 here. I'm going to multiply by 9 over 1 and by 9. Cross reduce, so you're left with your 1s. And then you have the absolute value of 3x plus 2 is equal to 54. Now you may start getting into your positive and negative equations as we've done prior. Our order of operations are done. So now we can start working in the positive equation. You wouldn't change anything here. You would just make it 3x plus 2 is equal to 54. The negative equation, 3x plus 2 is equal to negative 54. Because remember, we want to make a positive or negative 54 within that absolute value. Okay? So I'm going to start solving. Here I'm going to subtract 2. And same thing over here. I'm going to subtract 2. I'm going to do these all at once. We're left with 3x equals 54 on one side. The other one, we're left with 3x equals negative 56. Both cases, you're going to divide by 3. And now as you look at this and say, well, I don't get a whole number here, that's okay. We're going to have whatever value we get, even if they're fractions. We could leave this as 54 over 3 because 52 over 3, apologize. 52 does not divide equally by 3. I know that because when I add my digits together, 5 plus 2 equals 7, and 7 is not a multiple of 3. The same would be true of 56. It's not a multiple of 3 because 5 plus 6 is equal to 11, not a multiple of 3. So I could leave them like this. I could leave them as 52 over 3, and I could leave this one over here as negative 56 over 3. If you want to convert them into mixed numbers, you could, but those I would be completely accepting of because technically, when you actually go back and substitute, it actually makes your life a little bit easier when you're cross-reducing. So final solutions, negative 56 thirds and 52 thirds. Okay. So that's the first one. The second one, now we're going to work with, again, reverse order of operations. So I'm looking to isolate this 4y minus 1. Therefore, I want to subtract the 12 from both sides. There's my reverse order of operations. 7 times the absolute value of 4y minus 1 is equal to 7. Reverse order of operations. Now, remember, this is 7 times this quantity in here. So I'm actually going to divide both sides with my opposite operation. And now I'm left with the absolute value of 4y minus 1 is equal to 1. Now you can set up your positives and negatives. Positive equation, don't change anything. 4y minus 1 equals 1. Your negative equation, just change your solution here. 4y minus 1 equals negative 1. So you're going to find what values actually make this a true statement. I'm going to come up here and solve. I'm going to add 1 to both sides. And actually, it's the same step in both cases. I'm left with 4y equals 2. Over here, I'm left with 4y equals 0. Okay. Finally, I'm going to divide both sides. Everything is going to get divided by 4 because the equation is essentially the same. The only thing that's different is going to be my answer. Okay. Here, you can reduce your fraction. So you can make y equal to 1/2. Over here, don't get confused here. 0 out of 4. Remember, it's 0 divided by 4 is just 0. So our two solutions in the end here, y is equal to the set of 0 and 1/2.